In this video, we're going to look at atomic structure. So two definitions to start us off. An atom is the smallest particle of an element that is still recognisable as the element. A molecule is then a group of atoms that are chemically joined together. Inside the atom, there are three subatomic particles that we study in chemistry. They are the proton, the neutron, and the electron. You need to be able to describe the location, mass, and charge of each of these particles. The proton is found in the nucleus. The neutrons are also found in the nucleus, and the electrons are found in the shells. A proton has a mass of 1, a neutron has a mass of 1, and an electron has a very, very tiny mass. We say 1 over 2000. You can also give this in decimal form. The charge of a proton is +1. The charge of a neutron is 0 or neutral. The charge of an electron is -1. Some more definitions for us here. On the periodic table, we can find the atomic number and the mass number for an element. The atomic number gives us some information about that atom. It tells us the number of protons. This is also electrons for when we look at drawing atoms in the next topic. The mass number tells us the number of protons plus neutrons. This is always the bigger of the two numbers. Isotopes then are atoms of the same element, but they're different in that they have different numbers of neutrons. So they're atoms of the same element with the same number of protons, but different numbers of neutrons. That's a definition that comes up quite regularly, so it was one that I would learn if I were you. The relative atomic mass then, this one is also one we should learn. It is the average mass of an atom of an element compared with an atom of carbon-12. It sounds like a bit of a mouthful, but it is one that I would learn as well. We can calculate the relative atomic mass using this equation. So the relative atomic mass is equal to percentage abundance times mass plus percentage abundance times mass over 100. So in an exam question, they could ask you, calculate the relative atomic mass of magnesium given the following data. So it's told us magnesium 24 exists in 79%, magnesium 25, 11%, and magnesium 26, 10%. So the calculation that we do is our percentage abundance times mass plus percentage abundance times mass plus percentage abundance times mass, all divided by 100. When you do this in a calculator, you find the answer to be 24.31. This is also a question where they regularly ask to give your answer to a specific number of decimal places, so make sure you read the question.